Kinematics, part 2. So now we're going to look at kinematics from using integration. So first up, let's talk about what stuff means, right? So if you remember, we generally start off with displacement, which is s, also known as your position function, how far you are from the origin. Then we had velocity, right? How fast and which direction you're going. Then we had acceleration. Right, so when you took a derivative of position, you got velocity. When you took the derivative of velocity, you got acceleration. If you want to go backwards, you integrate. Right, so displacement is also just known as the integration of velocity. Same thing, right? That's what displacement is. You integrate velocity with displacement. So if you want to find the displacement from one time to another, what's the displacement, let's say, from 0 to 3 seconds? Like how far have you moved in the first 3 seconds? Well, you just integrate from 0 to 3. You used to have to plug in 0 and plug in 3, but now we just do that. So it makes stuff very easy. Now the key thing about displacement is, displacement is just about how far you moved from the origin, right? So like all this is all moving, look at positive velocity, this is all moving in the positive direction. That's just saying, hey, you started here, you went up 20 feet. What's your displacement? 20 feet. Easy, but that 20 is not the same thing. I gotta actually find the area of all this. It's a coincidence. Over here, what's going on here? Well, you're going forward, this is velocity, and then you're going back and you're going negative. So it's like this one's just saying, hey, you went up 20 feet. Then you stopped for a second, you went back down another 5 feet. My displacement there, well, they're working against each other. One's positive and one's going back negative. So the displacement's only 15 feet. Right, because displacement, it's all about how far you are from the origin. So in this case, all you did was move positive, so you're exactly 20 feet from origin. Find the area of that, you're good. This one, you're walking forward, then you're walking back. So they work against each other, so you have only 15 feet from the origin. That's displacement. So again, easy way to find it, just integrate from your 2 times. If I go back up here, I just want to point out that, right, your displacement, in this case is positive, right? If you're going positive direction, it's positive, so you're all good. Check. Just get your answer, you can get a positive answer. Over here, if you find a displacement of this one, you're underneath the x-axis, that's going to be a negative displacement. Not the best for us. Because if I say, what's your displacement? I just want to know, okay, you're 3 feet from the origin. This will be negative 3, so you got to watch out. So sometimes we're going to negate that answer to make it positive. So just keep in mind, right? If you're above the x-axis, it's positive. You're below, you're negative. If I ask you what's the displacement, we're generally talking about a positive value. So let's make it positive. Kind of like a good scenario. And that actually has to do with the next thing we're talking about. Total distance traveled. So the total distance traveled is how far have you walked. Right? So it's different than displacement. Displacement is how far you are from the origin. So I'm 20 feet from the origin. My total distance traveled in this case would actually be the same. How far you walked? Well, I walked 20 feet straight, so 20 feet. 20. Over here, though, it's different, right? You walked positive 20 feet, and then you walked back down 5 feet. So your total displacement's not 15. Well, your displacement's 15. Your total distance traveled, it's like a Fitbit. How far have you walked? Well, I walked up 20 and then walked back another 5. So I've walked a total of 25. That's the total distance traveled, right? It doesn't care that it doesn't care how far you are from where you started. It cares about how far have you walked in total. That's a different thing. That's more work. Because let's say I want to find the total displacement of this. I got to separate it. I got to find the displacement of this one plus the displacement of the positive of that one. Because otherwise it will work against each other. So how does that work? Well, it's a little annoying, but we do this. So without a calculator, the key thing is make a sign diagram. So let's say we had a sign diagram look like this. We started at 0 with the kinematics. Let's say you stopped at 2 and then went at 3. Went plus, minus, plus. And let's say they only wanted it for the first 4 seconds. Right? So how would I find the total displacement of this? Well, I gotta keep in mind that this is a positive value, this is a negative value, and that's a positive value. So when I integrate, I gotta separate it. Do the integral 0 to 2. Get my positive value. And then on the middle one, that's going to be negative. So I gotta keep in mind, so I'm separating it. This thing got to make absolute value. or negative or subtract it if you want, right? You gotta make sure this is a positive value because you just want to add them all up. And the last one's positive too, so I don't have to worry about that one. 3 to 4. So that's how we're gonna find total distance traveled if we have to do without a calculator. You gotta do a sign diagram and then add up each little partition. If you have a calculator though, lucky for you, it's easy. All you gotta do is use absolute value. Now here right now, IB generally lets you do this with a calculator. So if you're trying to find total distance traveled, all you have to do is integrate. Now notice with the absolute value, it's not on the outside like I did up here, right? When I did it on the outside, I wanted to make this thing positive. This is on the inside. That affects your graph. It may move your graph all up. So if you're doing the calculator, you integrate the absolute value of your function, right? Because in this case, this is all positive. You don't have to worry about it. In this case, it'll make it positive. So plus that plus. So that's keep in mind. The key thing to keep in mind is distance traveled. I shouldn't say, sorry, displacement. Is this a straight out integral from here to here of velocity? Total distance traveled, keyword total. You integrate the absolute value. And keep in mind, it's all just vocab, right? If you can remember the vocab of, oh, displacement, just integrate it. Total distance traveled, I have to take the integral of the absolute value, or I got to partition it. Then you're fine. It's just, the rest of it is just basic calculus. The hard thing for people is this a vocab. Make note cards, do whatever, but you have to know what you're talking about. Displacement is just basic integral. Total distance traveled is you have to partition it or do the absolute value. So let's look at this one right here. A particle P moves in a straight line with velocity of this. Answer the following using without a calculator. Oh crap. A, how far does P travel in the first 4 seconds of motion? Find the displacement. So this is B first. B is easier. Displacement, straight out integral. So we're gonna integrate from 0 to 4 of t squared minus 3t plus 2 dt. Now dt, because my variables are t, so I don't put dx on this one. That's all you have to do there. The first one says how far does it travel? That's talking about total distance. That's the absolute value one. So if I was using if I was using the calculator, just calculator the absolute value, t squared minus 3t plus 2 dt, and then I'm done. If I'm using without a calculator, I gotta break it up. So I gotta make a little sign chart. Remember the way you do a sign chart? We're doing a sign chart for velocity, which is what we have. So you set it equal to 0 to find your critical points. Factor it. So that's t minus 2, t minus 1. So my critical points are 2 and 1. So we start at 0. We got 1, you have 2, and then it wants the first 4 seconds, we're going to end at 4. So I have my sign chart. I'm going to get plug in test points, so plug in like 1/2. I'll tell you if you plug in 1/2 into that, you're going to get 1/2 minus that's a negative, negative, so positive. Plug in 1.5, negative, positive, so negative. Plug in something like 3, positive, positive, so positive. So that's my sign chart. Right, just like we always do find your critical points, plug them in, pick test points, plug it in, see if it's positive or negative. Once we have that, we accept the integral, right? So that integral is going to be normal. So it's integrate from 0 to 1 of my equation. T squared minus 3t plus 2. This middle integral is going to be negative. So again, this doesn't change anything. This means once you get your answer, make it positive. So I'm going to integrate absolute value of 1 to 2 of t squared minus 3t plus 2 dt. Right? Again, that's going to be a negative answer because it's negative, but we're going to make it positive. It's again, I don't care what the answer is. Let's say this one's 4. Let's say here I get negative 3. You want to make that positive, so it's just 3. And the last one, you do this one right here. That's a positive, so I don't have to worry about anything. It's just 2 to 4 of my integral. Then you plug it in. So then if you do that, you get your answer. I'm not going to do it because I don't have space, but also it'll take forever. But that's how you integrate it, right? Again, total distance traveled is the annoying one. That's when you have to break it up, or luckily, hopefully you can use a calculator. If not, you got to break it up and then do each integral individually. Make sure if you get a negative that you make it a positive because it should be positive. Displacement's the easy one. It's like, yay. You just integrate it. 0 to 4. Done. Okay, so we want to talk about this some more general, review some general ideas, right? So remember, displacement, take a derivative, get velocity, take a derivative, get acceleration. If you want to go backwards, you integrate. Now, why is this important? This is what IB loves to ask about. So they're going to do a thing where they give you, let's say they give you velocity. And they're going to say, find displacement. So you can integrate it, right? What happens when you integrate it? You're going to extend like x squared plus 3x plus c, because they're not going to give you limits. You got to remember, it's indefinite integral, so you have to put plus c. And what they're going to do is they're going to tell you, hey, the displacement at 2 seconds is like 15. So remember what we do with that? We use it to find c. And that's what these next practical problems are going to be like. IB asks this almost every year. They're going to be like, hey, this acceleration is this, find the velocity. Oh, here are these 2 points. Find your c. So that's a big thing IB likes to do. And let's do a practice problem like this. So let's look at this one. If the velocity of a moving object is given by v of t equals 32 plus 14 meters over seconds, if s is 16 when t is 0, find the displacement of the function. So again, notice I have velocity and I gotta go to displacement. That's, you integrate, right? To go one up. And look what they gave you. They gave you a point. S is 16, t is 0. They're telling you, hey, at 0 seconds, your displacement is 16. Find the c. That's what that's about. They want you to find c. So we have to integrate this. Right, it's a basic integral, 32t, sorry, we're doing t's. 4, add 1 to the power rule, divide by new power. So I'm going to get 2t squared plus c. And then what we do is we use this, right? When I plug in 0, I get 16. That's what that's telling me. So use that. So when I plug in 0, so my displacement equals this right now. I give myself that much room. That's why I'm stressing right now. Right, so when I plug in 0, it equals 16. So 16 equals 32t0 plus 2 times 0 squared plus c. So c equals 16. Again, that's not my answer, just like we did before. Generally, when you find c, that's not the answer. They want you to find the equation. So my displacement is 32t plus 2t squared plus 16. So now I have my displacement equation. So next question. Find displacement of the particle at the end of 3 seconds. So with that, you can do lots of different things. But the key thing to keep in mind is that the word displacement. Now, it didn't say find the position of the particle at the end of 3 seconds. If it did, I'll just plug 3 seconds into my displacement, my position formula right here. It says find the displacement. So they want to know what's the change from the initial spot to the end spot at 3 seconds. So you can always do s of 3 minus s of 0, and you get that answer. Because that's what displacement means. How far have you moved in the 3 seconds? So wherever you were at 3 seconds minus wherever you started at. Again, if it said position, then you just plug in 3. Now that's one way to do it. The other way to do it is using integration. Remember, the displacement formula is the integral velocity, in this case from 0 to 3. So you can do that, especially with the calculator, right? You just integrate 32 plus 4t from 0 to 3 dt. Now I did this earlier and I got 230. So my displacement in the first 3 seconds is 230. Oh, sorry, 210. 210. So again, so you can either do s of 3, plug 3 into the displacement formula, then plug 0 into the displacement formula, subtract them, or just plug it in. Use the velocity formula. Total distance traveled, remember that's the annoying one. So if you can do it without a calculator, you gotta do a little sign chart for the first 3 seconds of motion. Figure out where it changed direction. If I did it here, looks like it changes direction at -8. So the whole time would be positive or negative, whatever. Right, that's one way to do it. Do a sign chart, figure all that stuff out. With the calculator, you just integrate it. Absolute value, 32 plus 4t from 0 to 3 seconds. And that equals 210 as well. Because, again, if I found this critical point, my critical point there, so that equal to 0 would have been -8. So you don't really have a critical point within the range. So you get the exact same thing. But again, done with absolute value. This case does change. Show the object is traveling with constant acceleration. Now remember, acceleration, That's the second derivative. So you go back to your, you have velocity. Velocity is this. It's more of a review problem. I want to find the constant acceleration. Well, take the derivative. Derivative that goes away. Derivative that's just 4. Right? Acceleration is constantly 4. So let's try with the constant acceleration. The final problem we're going to do for this, just kind of sum everything up. A particle is initially at origin and moving right at 5 centimeters per second. So keep in mind what that means. Particles initially at the origin. So they're saying my displacement initially is 0. And moving at a rate, moving at right at 5 centimeters per second. So remember, moving is velocity. So they're saying the initial velocity, so we plug in 0, is 5. Okay, so then it goes on. It accelerates with time according to this. So to give me the acceleration formula, answer the following without using calculator. Without using calculator. So A, find the velocity function of the particle and sketch the graph from 0 to 6. Well, we have the velocity. Well, we have the acceleration function already. So right, if I have the acceleration function, I want to go to velocity. All I gotta do is integrate. I'm going to go up 1. So my acceleration is 4 minus 2t. And if I want to find the velocity, I'm going to integrate this. So the velocity equals, now it's a basic integration, it's a power rule. So if I have a constant, just add the variable. In this case, it's t. Over there, add 1 to the power, divide by a new power. So minus t squared. Now again, if we're doing indefinite integrals, right? So no limits means you have to add the c. Limits, you do top minus bottom. No limits, add a c. So that's my velocity equation. Except for the fact that you don't ever leave it with the c there, right? That's why they gave you this in the very start. They want you to find the c. You always have to find the c if you're going up or down. If they want you to find a function, find the variable. So in this case, let's plug our point in. My initial velocity is 5, so that means when I start it, when I plug in 0, I get 5. So 5 equals 4 times 0 minus 0 squared plus c. So c equals 5. So now my velocity equation is this. Let's make it a little nicer. T squared plus 4t plus 5. That's my actual equation. Luckily, hopefully it would be done, but this says they want us to graph it. So again, lots of ways to graph this. You could do the vertex, you get x-intercepts. Let's do the vertex. I haven't done that in a while. So my vertex is going to be negative b over 2a. So negative 4, because b is the thing with the linear term. A is the thing with the squared, so negative 1. Right? A is always the squared term, b is always the middle term, or the term with the first power. So I get negative 4 over negative 2, or just 2. So my vertex is 2 and something. Right? The way you find that something is you plug it in. Remember, this goes first because you're plugging into, so you always square it first. So it's 4, but then there's a negative on the outside, so negative 4 plus 8 plus 5. So I get 9, which means my vertex is 2 and 9. So if I was going to graph this, I'd go to 2, 9. And open down. Now, normally I'd just open down, right? Why am I opening down? Because it's a negative. I'll just open down and be fine with it. But my suspicion is that they want us to figure out the x-intercepts are because we're going to need it later. So let me do that real quick. If I wanted to find the x-intercepts, so I think we're going to need this in a second. Remember you said y equal to 0? So it would have been this. 0 equals negative t squared plus 4t plus 5. I don't like factoring with the negative in front, so I'm going to move everything over. So I'm going to t squared minus 4t minus 5 equals 0. Now I can factor really easily. Minus 5 plus 1. So my x-intercepts are at 5 and 1. Negative 1. So right here, 3, 4, 5. It's opening down. So I get that. That's my crude sketch. That's my crude sketch of that from 0 to 6. I think they wanted. So there's my graph. So right, I found my velocity equation. Then they wanted me to graph it, so I found the vertex and I put it in. I'm pretty sure they wanted me to find the vertex. We're gonna need that in a sec. The x-intercepts because we're gonna need that in a second. So I just did it. Now let's go on B. Look what B says. Find for the first 6 seconds. See. of motion, determine the displacement of the particle and total distance traveled. Now remember, one of them is easy, one of these is more annoying. The easy one is displacement. Displacement, again, it's just definitions. You know your definitions. I don't know what that is. Displacement is just, and it's in your formula sheet actually, is the integral velocity from t1 to t2. So that's in your formula sheet. You just copy down, oh, displacement, do that. So we have to plug it in. So we're going to integrate from 0 to 6. 4 minus, my velocity equation, almost messed that up, my velocity equation. Negative t squared plus 4t plus 5. Right, you can integrate it, get your answer. I tried to do that. That's an important one. That's too easy. Let's talk about total distance traveled. That's the annoying one. So total distance traveled is when you have to break up. And actually, I just looked it up. I was wrong. Displacement's on your formula sheet. You just gotta know that one. Total distance traveled is on your formula sheet though. So you look at your formula sheet, it would say this. And that's your hint to, if you're gonna do this without a calculator, you gotta break it up. If you have a calculator, which most of the time they will give you a calculator, they will give you a calculator most of the time for this one, you just plug it in with the absolute value. But if we're gonna do it without a calculator, break it up. So let's do that. We'll do both ways actually. So they want total distance traveled. So look at your formula sheet and it's this formula. It's integral absolute value v. So we need a sign chart. Luckily they made us graph it already. So again, we always start at 0. It's one thing we really care about. And then it's positive until it's above the x-axis, positive until you get to 5. Now remember, they only wanted the first 6 seconds. So my integral is going to be something to 6. And from 5 to 6, it's negative, so there. So again, if I'm doing this by hand, I got to integrate 0 to 5 of my velocity equation, which is negative t squared plus 4t plus 5 dt. Plus, I got to do the absolute value of this one. Integral of that one. So we're going to integrate from 5 to 6 of negative t squared plus 4t plus 5 dt. Right? Get my answer there. Let's say it's 2. Who cares? Get my answer there. Let's say it's negative 3, but I need the absolute value because I want to make sure it's positive. And you add them up. Get your answer. Again, I just made that up. If you're going to do it with the calculator, then all you do is plug that into your calculator. You can literally plug in 0 to 6, absolute value of your integral. You plug that in your calculator. So that's how you do it. Remember, the main thing for this lesson, the main thing I want you to take away is that you should know how to go from displacement to velocity to acceleration, right? It's all derivative, SVA. If you have to go back up, then you integrate, right? All stuff we should know, right? So SVA, displacement, velocity, acceleration. Go down as displacement, go up as integration. If I want displacement, that's just a straight out easy integral. T1 to T2, where your displacement is, or your velocity function. If I want total distance traveled, that's the annoying one. That's in your formula sheet though. That's T1 to T2, absolute value of velocity function, right? That's the hint of, if you can do it without a calculator, you have to break it up. If I want the absolute value, you have to break it up and do the separate ones. So that's that lesson.